Hello, this is Professor C.P. Prakasham, former professor from International Institute for Population Sciences, Mumbai. I will be discussing about analysis of variancy, one-way analysis of variance. In our statistical analysis, the significance difference between the two sample means can be judged either through T statistics for a small sample or Z statistics for a large sample depending upon the criteria. To evaluate three or more means, we have to use the analysis of variancy. There is a statistical procedure of analysis of variancy and it is abbreviated as ANOVA. ANOVA is a parametric test. The basic procedure is to derive two different estimates of population variancy, that is given that between the group variancy and within the group variancy from the data, and calculate the ratio of these estimates by using the F ratio or F statistics. F distribution is calculated to determine whether the two sample from the same population have different variancy. Also, it will test the significance, indicating that population means are probably not equal. That is our hypothesis. We have to decide on that basis. Before doing the analysis of variancy, we should satisfy the assumptions which are involved. The important assumptions are the population normality and homogeneity of variancy. The population from which the sample has been drawn should be normally distributed. This can be checked by using the descriptive statistics, that is skewness, and also Shapiro-Walk test can be used on that. For a homogeneity variancy test, the scores or observations measured in numbers, that is not the categories, in each group should be homogeneous variancy. For this, Leibniz test will be used and it can be proved on the basis of the Leibniz test in the analysis of variancy. These two assumptions can be met by using the SPSS, that will give directly from that. ANOVA carried out with one factor and dependent variable is named as one-way analysis of variancy. Two factors or two dependent variables can be considered and it is also called the two-way analysis of variancy. If there are more number of dependent variables and one independent variable is there, then it is called a ANOVA, that is multivariate analysis of variancy. Now we will discuss one-way analysis of variancy considering with one factor. In the one-way analysis of variancy, there are two types of variances considered. One is variancy between the groups and variancy within the groups. For that, null hypothesis is set as a sample group means are equal. Though analysis of variancy discussed with the variancy of that, alternative hypothesis is that one or more groups mean differences from the other one. The test statistics, that is F test for the one-way analysis variancy, is considered as F distribution is calculated to determine whether the two samples from the same population have different variances. F test is, that is as discussed earlier, F equals to variancy between the groups divided by the variancy within the groups. That is the ratio of the sum of squares of the variances of the group divided by the degree of freedom, sum of squared variances of the within the group divided by the degree of freedom of that particular group. According to the equation of variancy, S square is the summation of square of deviation of number of observations from the mean divided by the n minus 1, that is the degree of freedom of that observations. Therefore, this after calculating that, F ratio will give the decision power. To summarize the results of analysis of variancy from one factor, the following table has to be generated. That is, between the sample or between the groups, sum of square deviations, degree of freedom and mean square, and then Similarly, for the within this sample or within the group, we have to calculate the sum of squares and degree of freedom, that is n minus k, and mean squares will be calculated, and the ratio will be calculated between the mean sum of squares between the groups divided by the within the groups. That will give the F ratio. That F ratio will be looked to the calculated standard values of F from the table. The F ratio value, we have to make the decision about the hypothesis. Therefore, if the calculated p value is less than chosen value of 0.5 level, 0.05 level, then accept the H naught. Similarly, if the calculated p value is greater than the F table value, reject H naught. Therefore, our null hypothesis that sample mean is H naught are equal. Alternative hypothesis H1, one or more groups of mean are different from the other, can be judged on the basis of the acceptance or rejection of that. We will illustrate the analysis of variance, one-way analysis of variance by an example. A researcher is interested to compare the household income in 4 selected cities. A random sample of 20 households from each city is selected, and per capita income in 1000 rupees is calculated and given in the data table right side. Here, one of the assumptions is that the sample which has been derived, that is the per capita income of the 4 cities are different, and the sample of the household which has been selected within the cities are selected on the basis of the statistical procedure which satisfies the representation of the total population. By using this SPSS, we can calculate one-way analysis of variance with post hoc analysis of variance. That is for the testing of that. How to run the ANOVA? First you select Analyze menu, click Compare Means and one-way ANOVA. Select dependent variable, here it is per capita income, and select independent variable, that is city, under the factor, and click post hoc comparison and Turkic test, and continue. You will get the analysis of variance. Let us go to the SPSS and see how to calculate that. This is the data where the city is entered in one column, one below other, with the names and all these things, and this is the per capita household income is given in the second column. And when you look at the variables, the city is a numeric, and then it is coded as one is one particular city by name New Delhi, and number 2, number 3, number 4. There are 4 cities are there for the data is existing. Then comes the per capita household is the dependent variable, it is given in the second variable. Then go to the Analyze, Compare Means, and then one-way analysis of variance, and click that. Once you click that, you will get the 2 variables here. One is the dependent variable, another is the factor. This factor you bring it to the factor here, click, and per capita household you click to the dependent list. Since we are doing one-way analysis of variance, we are having only one dependent variable. And then go to the post hoc for testing the homogeneity and other things, and then say to key, click, and afterwards significance level you keep 0.05 and then continue. Once this is done, then we will select the options. These options are descriptive statistics, homogeneity of variance test, and means plot. These are the important things for us, and other things also can be done according to the requirements. And then click OK, continue. Once this is done, and say OK. Once you have done OK, then you will get the output. This is the output which gives that syntax as well as one-way analysis of variance, homogeneity test of variance, and analysis of variance output, post hoc test as well as homogeneous and means plot is given. Output of one-way analysis of variance derived from the SPSS. It shows clearly here that this table gives you, the first table is the descriptive statistics, which gives that the city-wide descriptive statistics, which will give the mean, number of observations, mean, standard deviation, standard error, confidence interval, and minimum and maximum number of observations which you have taken. If there is any missing value is there, that will be represented here. And the, as we had discussed earlier, Leibniz test of equality of error of variance, it shows that the null hypothesis that the error of variance of the dependent variable is equal across the groups. This is the example of p-value here in this example, 0.894. Therefore, we fail to reject the null hypothesis. This satisfies the assumption for conducting one-way analysis of variance. Therefore, Leibniz test will give you the homogeneity of variance. If it is not satisfied, then we cannot conduct the analysis of variance. After conducting the analysis of variance, the table is given here. That will give the between the groups, within the groups, and degree of freedom, mean sum of squares, and F ratio. Whether the F ratio is significant or not is given. Here it is written as a analysis of variance table shows the mean household income is significantly different for at least one of the city, with the degree of freedom is less than, p-value is less than 0.003. Therefore, from this analysis of variance alone cannot judge. Therefore, we have to conduct the post-hoc test to perform this. By using the two-key test, that will give you the multiple comparison table, which reveals that mean household per capita income in Chennai with Mumbai, Chennai with Calcutta differ significantly. The difference in the mean household income is clearly explained by the graph also. Here when you look at the table here, the first mean differences also given the significance. That is, a city called Mumbai and with Chennai, there is a significance difference is there, and mean difference it is calculated as 8.50, where it shows the significance also, and for which upper and lower bounds of the confidence interval is given. Similarly, for the Calcutta with Chennai, there is a significance difference. Chennai with other two tables, other two cities also given, but not with Delhi. That shows clearly that mean household income of Chennai is differ with a city called Mumbai as well as the Calcutta significantly than the a city in the New Delhi. By drawing the mean plots, it is clear that the variations of the household income between the cities. The mean plots is a visual representation of the means of the data set, shows that mean household per capita income of the Mumbai sample household found to be the highest, that is the here, that is 85.85, highest when compared to others, followed by Calcutta, Delhi, and least in the Chennai. The conclusion is that we do have sufficient evidence to reject the null hypothesis, hence that the means of the household per capita income of the four cities are not equal. There is a variation. The group mean are different. From the graph, mean per capita household income significantly lower in Chennai than Calcutta, Delhi, and Mumbai. This will give you the manual calculation of the entire data set. When the data or sample is very small, one can calculate by using the hand calculation. Otherwise, they can use the SPSS. This shows that the household number, the per capita income of the households of the different cities. Then down below you can see the sum of the all the per capita income, mean of the per capita income, and mean of the mean per capita income is given. Similarly, between the groups and within the groups, and analysis of variance is calculated, and F ratio is calculated as a significant. This is possible when the sample is very small. Thank you very much. Please subscribe it, share it, comment it, and write a mail to the given email ID. Thank you very much.